Okay, Jarek, the floor is yours.
Thank you, Alexander. Good afternoon for everybody. I hope you hear me well. So my presentation is about overheating in Estonian new apartment buildings. So these are lately built modern apartment buildings, and we studied summer thermal comfort effects. So as you know, summer thermal comfort is addressed in the directive, so that energy performance should also reflect avoiding overheating, and this is implemented in Estonian legislation, so that there is a requirement for residential buildings with limit maximum temperature plus 27, and you can have 150 Kelvin hours excess over that value during the summertime. And this is a bit more strict requirement for non-residential buildings, which operates with 25 and 100 Kelvin hours. So this is a simulation-based procedure. So basically, it's intended for new buildings and needs to be done together with EPC calculations before you apply a building permit. The principle of that requirement you can see here. When you have room temperature during 3 months on the left graph, and as it is all the time fluctuating, then you can make a duration curve, and what you are interested is the excess over the 27. So this is basically the area marked with red in that right graph. And in residential buildings, window airing is taken into account when these temperatures are simulated. All, let's say, use of a building is a standard use. A test reference here is used, and it's a simulation-based procedure. And to calculate these excess hours and to see that they are below the limit of 150 or over, it is very easy if you have hourly temperature simulation data, as you can see in that fragment of Excel table, where you just calculate the excess over the 27, and then as they are hourly values can be just summed up to end up with excess value which should be less than 150 Kelvin hours. So in this study we had 25 new modern apartment buildings involved. They were basically randomly selected, and we did a lot of simulations. Close to 160 dwellings were simulated, and also there were some measurements to see the real measured temperatures. This is some photos about the temperature measurements with very simple lockers, and there are some examples of these buildings you can see, and also these critical apartments which have a highest risk for the overheating are marked, at least in one building, and it is indeed one complication of this kind of a method that nobody has capacity to simulate all apartments in the building, but it is needed at least 2 most critical apartments are to be simulated. So it needs a careful selection of these apartments most probably having most severe overheating problems to have a successful results. And indeed for that purpose guidance is needed how to select these apartments. And simulation procedure, it is with test reference year, so it is fixed. And you can see, for example, with 2014, when we did measurements, it was much warmer compared to test reference year. So you cannot expect that the simulated results with test reference year and real measurement results will be the same, because already weather data is different. In the simulation, standard use needs to be defined, so it applies for the lighting, appliances, and occupants schedules, which can be seen here. And then it is also allowed in residential buildings to take into account the window airing. This is defined so that the windows can be opened to the airing position. So it's you cannot fully open the window in the simulation, but it is allowed to the airing positions, as you can see from the photo, and this needs then to be defined in the temperature simulation. So if somebody is using more simple simulation software, then it is not possible to take into account the window opening, and then results will be conservative, so there could happen more overheating than in the case if openable windows are taken into account. And indeed, this is also very important to specify correct window parameters in the simulation, because they have a very strong effect on results. Now I am showing some results. So these are actually from the measurements, and they show that the last graph shows a nice correlation between excess hours and openable window area. So if it is below 5%, then temperature excess values start to be very high. And then it is also very important window to wall ratio, which can be seen from the right figure. And it is window to wall ratio is multiplied with G value. So this was a representative parameter, and when if this value is less than 0.2, then basically overheating is under control. And we were able also to determine how much shading balconies or side fins need to be provided, so which overhang is needed in the south orientation, and balcony is the best possible passive shading or overhang, and in the west orientation you cannot operate with overhang, when you will need some sort of side fins or other type of external shading to control west orientation. And in this way it was possible to determine also some design guidance, how to tackle overheating problems, what is very useful for the architects and designers, so they already know basic solutions, and then temperature simulation will just show are the results compliant and not, and you typically will not need big changes when you will run the simulation. So what was not so good result was that only 17 of studied 25 buildings, sorry, not 17 did not comply. So it was only 8 buildings which complied with the regulation. You can see the result here, requirement of 150 Kelvin hours, and those buildings complying are marked with green, and all other ones are red. So basically there is a group of buildings which is quite close, but still higher than 150 Kelvin hours. So showing that this requirement, which is actually very new requirement in Estonia, starting from 2008, was not fully established in the practice. So Measurement results really confirmed that high temperatures over 27 did exist also in reality in many of buildings, and so it is easy to have a high risk of overheating in new modern apartment buildings, which are indeed well insulated, and window surfaces can be very large. Many occupants also had complaints, but we did not collect this occupant response data systematically in this study. Shading balconies had the largest effect on overheating risk reduction, and we were able to define what are the important basic parameters of a critical room. So it's south and west oriented windows, lack of external shading elements, or insufficient dimensions of shading. So, and this window to wall ratio multiplied by G value higher than 0.2, and total windows airing area less than 5%. In such a case, overheating will most probably happen, and based on these factors, it is also easy to select these critical rooms which will be used to run the temperature simulation. So from compliance point of view, out of 25 studied new apartment buildings, in 17 buildings did not comply with this summer thermal comfort requirement. So this shows that this relatively new building code requirement was not fully established in practice, and actually only 8 buildings had required calculations and documentations included in the building permit design documentation, and actually only 8 buildings were complying with this requirement, showing that if you will run these temperature simulations and then apply necessary corrective actions, measures, then this requirement can be fulfilled fully with passive measures. So it's basically no need to apply mechanical cooling, but passive measures should be applied when it is possible to achieve. And our results also showed that measured and simulated results cannot be directly compared, because there are differences in the weather data, and occupancy and other internal gains are not exactly the same as a standard use of a building. So for the compliance assessment procedure, always simulations are to be used. Indeed, we can do a validation study which will show that simulation and measurement result can be very close, but this is for the research purposes and methodology development. And overall, the methodology proved to be sound and robust, so this really can be used in the overheating assessment. Thank you. That's all from my side, and I've understood that the questions will be later at the end of the webinar.